Hi everyone, welcome to Code Management. So today we will discuss about the transactional annotations part 4, which is the isolations. So first of all, I will discuss about the concurrency problems, and then I will discuss about the isolations, like isolation levels, why the isolations came into picture, right? So isolations basically ensures the consistency of the data in simultaneous operations and is a structure that isolates and protects the integrity of the data. There are several types of concurrency problems. So mainly these three problems are there: the dirty read problem, non-repeatable read problem, and phantom reads problem. So one by one I will discuss. So first one, the dirty read problem. So see, at time t0, the transaction A attempts to update the price as a $1,999. And at time t1, the transaction B reads the data for a product with ID 1001. And by time t2, some exception happens. And that's why this update has not happened. But as transaction B already read the data, the updated data, this $1,999 of the product, so it leads to one inconsistency. So this read problem, like this situation, results to that the client observes incorrect information. So this phenomenon is referred to as the dirty read problem. Okay. So next is non-repeatable read problem. So what is this non-repeatable read problem? So at time t0, the transaction A reads the product with ID 1001, suppose $1,000. And then by time t1, transaction B updated the price of the product to $1,999. And there was no exception, and this at the point of t2, it committed. So at time t3, when again transaction A reading the data, like the price of the product, it reads the 1001 ID, like product ID, and it read that the price got updated to $1,999. So there is a gap between these two data. So these data are not equivalent. Okay, that transaction is determined. So as a result, this phenomenon is referred to as a non-repeatable reads. Next one is phantom reads. So phantom reads is pretty similar to this non-repeatable reads, but there is only one difference between them. So non-repeatable reads is valid for one column, but phantom reads is for valid for the data set. So for instance, at time t0, transaction A reads the product with ID 1001, and by time t1, like this transaction B updates the data set of the product, and it has several columns, suppose name, price, descriptions. Okay, so with ID 1001, and it got commits at time t2, and transaction A needs to read the data again at time t3. It reads the product ID 1001, and it compares the two sets of data, the initial read at time t0 and the latest read at the time t3, and those are not equivalent. And as a result, this phenomenon is referred to as a phantom read problem. So in Spring, transactional annotation contains the isolation level property, such as default, read uncommitted, read committed, repeatable read, and serializable. These are the levels. But Spring transaction uses the default isolation level. It means the default isolation level of the database. So what is this default? So that is basically the default isolation level of the database. So suppose when you will give one isolation, so default you need to set like isolation.default. So Spring by default use this one, so we don't need to add anything for. Next is read uncommitted. So there, suppose propagation I have explained in the part 3 video, okay, of transactional, just before of this video. So you can read about this propagation. So here you can see isolations, we have set it for read uncommitted. So this is the lowest level of the isolation, and it allows many simultaneous accesses, and it cannot prevent problems with concurrency. Like it cannot solve the dirty read or phantom read problem or the non-repeatable read problem. Okay. Now read committed. So read committed is the second level of isolation. So here the dirty read problem got prevented, and but the other problems like the non-repeatable read problem or the phantom read problem, those problems of synchronicity can occur. Okay. Next is a repeatable read problem. So repeatable read is the third level of isolation, and it basically prevents the data read and non-repeatable read problem. Here we just said this isolation dot read like repeatable read. Next is serializable. So it's the highest level of isolation, and it prevents all the concurrency problems, like all the data read or the non-repeatable read or the phantom read problems are got prevented. And it executes the concurrent calls sequentially, and it is expensive in terms of performance. So this is the highest. So isolation dot serializable. Okay. Now some other attributes I'm just talking now. So first one is timeout. So the timeout for transaction is in seconds. Like for a specific timeout, if you want to set, you can set as at the rate transactional, and then timeout equals to 30. 30 means 30 seconds. Now next is read only. So if it is set as true, the transaction is allowed only to read operations, not modify them. The default is always false, but you can set it as true when you want to allow to read the operations, not to modify. Next is rollback for. So that is like custom exceptions, like transaction only triggers rollback when encountering a custom exceptions, what you want to specify. But for other cases, it just want try to commit. Okay. So these are the things actually. So whatever concurrency problems are there that I have discussed, and after that, the levels of isolations I have discussed, and then some other attributes also I have discussed. Right? So that's all. Next, we will meet again in the next lecture. So till then, stay tuned to like, share, and subscribe. Go to the playlist, Spring Boot discussion, and just see the videos. I think those will be helpful for you for your upcoming interviews and like project works. Okay. So that's all. Thanks everyone. Bye.